Let's go to guided practice 2. Use the binomial theorem to expand cosine theta plus I sine theta to the fourth power. Give your answer in the form a plus bi, where a and b are expressed in terms of sine theta and cosine theta. Let's go to Pascal's triangle. So a plus b to the fourth power equals 1 plus 4 plus 6 plus 4 plus 1. A to the fourth power, a cubed, a squared, a to the 0 power, b to the 0 power, b squared, b third, b to the fourth power. Organize a to the fourth power plus 4a cubed b plus 6a squared b squared plus 4ab to the third power plus b to the fourth power. Then we will make a equals cosine theta, b equals I sine theta. So we get cosine theta plus I sine theta to the fourth power equals cosine fourth power theta plus 4 cosine cubed theta I sine theta plus 6 cosine squared theta times I sine theta squared plus 4 cosine theta times I sine theta cubed plus I sine theta to the fourth power. We do know I squared equals -1, I cubed equals I to the fourth power equals 1. Organize cosine fourth power of theta plus 4i cosine cubed theta sine theta. I squared is -1, negative sine squared theta. So minus 6 cosine squared theta sine squared theta. I cubed means -I sine cubed theta. Therefore, -4i cosine theta sine cubed theta. I to the fourth power sine fourth power of theta. I to the fourth power equals 1, so we got plus sine fourth power of theta. We will put real part of a complex number together. So we got cosine fourth power of theta minus 6 cosine squared theta sine squared theta plus sine fourth power of theta plus 4 cosine cubed theta sine theta minus 4 cosine theta sine cubed theta I. Check the exponents. The sum of exponents in each term should be 4, which means you will be on the right track. B. Use DeMoivre's theorem and the result from part A to show that cotangent for theta equals this. Based on DeMoivre's theorem, we got cosine theta plus I sine theta to the fourth power equals cosine 4 theta plus I sine 4 theta. Therefore, cosine 4 theta equals this, which is cosine 4th power of 4 theta minus 6 cosine squared theta sine squared theta plus sine 4th power of 4 theta. Sine 4 theta equals 4 cosine cubed theta sine theta minus 4 cosine theta sine cubed theta. For cotangent 4 theta equals cosine 4 theta over sine 4 theta equals cosine 4th power of 4 theta minus 6 cosine squared theta sine squared theta plus sine 4th power of 4 theta all over 4 cosine cubed theta sine theta minus 4 cosine theta sine cubed theta. Then you compare these two expressions together. We need a 1. So numerator and denominator divided by sine 4th power of 4 theta equals, first term should be cotangent 4th power of 4 theta minus reduce. Then we got 6 cotangent squared theta plus 1. Denominator reduce. 4 cotangent cubed theta minus 4 cotangent theta. Let's go to C. Use the identity from part B to show that the quadratic equation x squared minus 6x plus 1 equals 0 has roots cotangent squared pi over 8 and cotangent squared 3 pi over 8. This is the result from part B. First step, solve cotangent 4 theta equals 0. Let's go to this unit circle, CST. This is the angle 0 pi over 2 pi, 3 pi over 2. This is 2 pi. Since cotangent theta equals 1 over tangent theta, we got undefined for cotangent theta here. Then we got 0 for cotangent theta, 0 for cotangent theta. Here, undefined for cotangent theta. For tangent and cotangent, the period is pi. Therefore, we will use pi over 2 as the reference angle. 4 theta equals pi over 2 plus k pi equals, denominator is 2, pi plus 2k pi. Then theta equals pi plus 2k pi. over 8. Then 1k equals 0. Theta 1 equals pi over 8. 1k equals 1. Theta 2 equals 3 pi over 8. Second step, since cotangent for theta equals this, we will make the numerator equals 0. Cotangent for theta minus 6 cotangent squared theta plus 1 equals 0. Let's go back check. We need a quadratic function. So we will change this into quadratic function, which means cotangent square theta squared minus 6 cotangent squared theta plus 1 equals 0. So we assume x equals cotangent squared theta. We got x squared minus 6x plus 1 equals 0. So cotangent squared pi over 8 and cotangent squared 3 pi over 8 are solutions to x squared minus 6x plus 1 equals 0. Let's go to D. Hence, find the exact value of cotangent squared 3 pi over 8. We know x squared minus 6x plus 1 equals 0. Using quadratic formula, 2 times 1, 6 plus or minus square root. 6 squared minus 4 times 1 times 1. So we get 6 plus or minus square root of 32 over 2. Square root of 32 is 4 square root of 2 over 2. Reduce 3 plus or minus 2 square root of 2. Since cotangent squared pi over 8 and cotangent squared 3 pi over 8 are also the solution to this quadratic equation. Therefore, either cotangent squared pi over 8 equals 3 plus 2 square root of 2, or cotangent squared 3 pi over 8 equals 3 plus 2 square root of 2. Let's talk about this unit circle. Since pi over 8 and 3 pi over 8 both in the first quadrant, we got cotangent 0 equals undefined. For angle pi over 2, 0, 1, undefined 0. CST cotangent pi over 2 equals 0. So for angle 0 to pi over 2, for cotangent, it's from infinity to 0, which means cotangent is decreasing in the first quadrant. In other words, for cotangent squared pi over 8 greater than cotangent squared 3 pi over 8. So cotangent squared 3 pi over 8 equals 3 minus 2 square root of 2. Let's go to E. Deduce a quadratic equation with integer coefficients having roots cosecant squared pi over 8 and cosecant squared 3 pi over 8. we do know for x squared minus 6x plus 1 equals 0, cotangent squared pi over 8 and cotangent squared 3 pi over 8 are the solutions. We know cosecant squared theta equals cotangent squared theta plus 1. So we get cotangent squared theta equals cosecant squared theta minus 1. Therefore, for cotangent squared pi over 8 equals cosecant squared pi over 8 minus 1. And cotangent squared 3 pi over 8 equals cosecant squared 3 pi over 8 minus 1. So we plug into this quadratic function. To make things easier, let's make these two roots as y1, y2. So we get x equals y minus 1. Plug into this equation. Y minus 1 squared minus 6 times y minus 1 plus 1 equals 0. Simplify. Y squared minus 2y plus 1 minus 6y plus 6 plus 1 equals 0. So we got y squared minus 8y plus 8 equals 0. This is the quadratic equation we are looking for.